Hi guys, today I'm going to show you what I've been working on for the past few days. Alright, so it's about the flooding visualization based on Ca2D. So there's two directions I've been looking at the same time, because when we think about it, this visualization slash game thing work in two situations. One, we've got a fairly small-ish game that can be simulated in real time because it's small enough, so we can have a visualization system which could be like a web-based one, like the games we've done so far. So I've tried to visualize something I can visualize Ca2D web-based that's compatible with the games we've done. That's only going to work for small enough problems because of the limitation, the technical limitation of the WebGL thing. So, and then there's the other direction, which is something you can display a whole town or more in quite accurately in 3D with all sorts of stuff. But then you can't really simulate this vast stuff in real time because it takes not just like a few seconds for Ca2D to compute that kind of flooding thing. So so this would use a more C++ or C# based game engine, such as existing commercial engine that I've been playing with recently. So okay, so this is two different directions I've been working on at the same time. So first one, let's have a look into the WebGL based thing. It's still a prototype, of course, but well, it's getting there. Alright, so it's available to see at the web address. It takes a while for the website to download because it downloads the whole data from the data from the torquay problem. So there is a Ca2D thing, GPU calculated about torquay, and I take this data as input. I take the very last frame of flooding. So as you can see, from a WebGL point of view, it can handle the size of this torquay dataset problem. So you can, see the terrain, watch the whole thing. Notice that I still need to work on animating from frame to frame, but if you look closely, you see that there's a slight, it's not completely flat blue things. It's following the data from Ca2D, which kind of follow the terrain a little bit, and I over elevate it slightly compared to the terrain around it, so that the polygon sticks out. But it's not even perceptible visually. Okay, so it works pretty well. The whole terrain is at 60 frames per second, represented perfectly. Not much to say. Yes, animation. So far I'm only showing the last frame of the Ca2D result for torquay, and this is deformable. I'm working on the high speed animation, because if you look at that, I can just deform in real time the terrain by a height scale factor for visualization purpose, and you can see it's very smooth and quite fast. So I'm trying to find a solution to do at the same speed the animation for changing the flood map, the blue one, because actually the flood map is exactly the same as it's a 3D representation like the green one, but with a little bit higher points where the Ca2D results come out. So yeah, I'm trying to get that animation, so I could have data from flooding frame 1, data from flooding frame 2, and instead of just morphing, just changing flooding frame 1 and replace it immediately with frame 2 for flooding, I would have a morphing function that would change slightly the height in a linear fashion between the frames. and now I've got the stuff set up in 3D. I'm trying to get the most optimal way to do that, because normally it's quite slow, considering that in the case of torquay you got 1600 by 2500 or something like that of data for the flooding, the number of pixels used by Ca2D. That takes a while, because it's more than, you know, it's more than a million things to, it's a vast amount of data, even though it doesn't look like it to change. So this takes a while to I need to find an optimal way to do that change. But that's on the WebGL side. I've also in parallel investigated some game engine. So the first one is Unreal. I've also looked at the Amazon Lumberyard game engine, which is the very latest tech coming from Amazon, but it's still a little bit of a beta version thing, so there's still a bit buggy, so I'm not going to use it. But at the moment I'm going to show what I'm representing in an equivalent way in Unreal. This would be for a bigger game scenario with many more buildings to see and things like that. So there is a couple of things, technical problems I'm trying to work my head around with Unreal, but let's see what it gives me at the moment. You see, it's quite equivalent, except that the Unreal is much more powerful, Unreal Engine, so you could visualize thousands and thousands of buildings and the whole town if you want to, and probably all the data you've got from all around the place. I mean, it's C++ based, so okay, let's just play it. So for the Unreal, I've got this wooden table. Alright, and this is the terrain here. There's a nice little lake shader for the water, and as you can see, well, it works as well. Looks probably a little bit better. Okay, so that's the same torquay data set, but with a more powerful vision of the Unreal Engine, and it will be easy to add the buildings on that one. So yeah. Okay, so this is what's been done so far, and similarly I'm looking at the Unity engine, so that I can find an optimal solution for animating the water when it goes up and down. I'm still not done with finding the optimal, fastest way to do that. Alright guys, this is the update so far. I'm using torquay because it's fairly big as a data set from Ca2D, so if I can use that as a demonstration thing, then that means it's fairly good in both systems anyway. Alright, bye bye.